Hello. So we all know that drones have come a long way in the last 5 years. They're not just machines that are used for producing cool marketing video. You can actually use drones for a number of different use cases. And one of the use cases that keeps coming up often is actually the use of drones in solving difficult access. So if you are a property manager, or if you're an engineer, or if you're a contractor, and you're trying to actually solve the problem of difficult access to be able to do a roof inspection, you can actually use drones to now effectively map, inspect, measure, quantify roofs in a fraction of the time that it used to take you with the conventional methods. So, to be able to understand how this all works, we're going to actually go through an example project where we're going to look at a roof where access is challenging because of the structure of the roof, and therefore using a traditional method like a cherry picker, a scaffold, or any other method you can think of could actually be really expensive, and using a drone to be able to do the inspection actually provides real efficiencies that you can bring to your projects. Let's have a look. Right, so what are we going to be looking at is basically a roof that has difficult access as part of its part of its design. So I've got Google Maps at the moment to bring you to the site that I'm talking about, and if I zoom around this site and really sort of show you the roof in 3D, you'll very quickly realize that this is a roof that can be quite challenging to inspect by simply getting on the roof and walking over the roof. And so how do you inspect something like this is what we're going to solve in this video. Well, all you have to do is use drones to be able to capture the roof in the right way, to capture images of the roof in the right way. And so what we're going to do in this video is begin to look at using hammer missions to plan your drone flights, and then to essentially process and inspect all of your data and analyze all of the different metrics that you want to understand about the roof. Let's begin. So the first thing we're going to do in this particular project is we're going to look at how do you actually plan the flight plan for your specific task. So essentially for mapping out this roof. So I've got the same roof that I had before on screen, the same one that you saw on Google Earth. I've got that now in Hammer Missions, and I'm going to create a flight plan. So I'm going to go into my flight planning menu, and I'm going to choose my 3D modeling flight plan, as that's what we really are interested in this particular roof. And I'm going to drop a few points, a few polygon on top of the screen, and essentially hit enter. And that's going to create a flight plan for my drone to actually map out this roof. Once I've got that flight plan, I can actually go and adjust all the different settings. I can sort of say, I can choose what drone I'm capturing this for. So I'm actually going to capture this with a Mini 4 Pro, which is a sub 250 gram drone. And that allows you to actually fly in most areas without additional scrutiny in terms of the different permits you might require to be able to capture the roof. Now, of course, you still need local authority permissions, or you require CAA or FAA permissions, depending on where you're flying. But having a sub 250 gram drone with a high imaging camera can actually allow you to get really good data, and also reduce the regulatory burden that you might have with respect to the flight. So once you've chosen the flight camera you want to fly with, you can choose the altitude. So in this case, we know the building's height roughly, and so we're going to go for 120 meters. We're going to add the building height. So that's going to be, in our case, somewhere around 60 feet. And we're going to fly at 120 feet. We're going to set overlap. So this is amount of overlap between every two images, and we're going to set that to 80% by default. Flight direction is going to be default. Gimbal tilt was going to be default at negative 70 degrees. Flight speed is going to be 3 meters per second. And we can add smooth corners to our flight plans. So in case you're not very familiar with flight planning, we have lots and lots of videos in terms of how you can actually do your flight planning. So feel free to go check out some of those videos if you're curious about flight planning. But essentially, at the end of your flight planning, you'll end up with a flight plan that looks a bit like this, sort of a waffle crisscross pattern across the roof. And the gimbal angle is going to be negative 70 degrees. So it allows you to actually capture different parts of the roof as your drone is flying. And you can see this both in 2D and in 3D. So once you've got your flight plan, you can basically sync that flight plan with your with the Hammer app. So you just press the sync with app button, and then that sort of flight plan gets transferred to the drone controller where you can actually go and fly this mission. So we're going to now take you to site, show you a couple of videos from the site in terms of how this is being flown, and then we'll be back with the data analysis in Hammer missions.
So here today we're going to use the DJI Mini 4 Pro to capture the building outline of a building we want to fly, and after we've captured that building outline, we'll generate a 3D mapping mission to fly around the roof of the building and capture the roof area as well as the facade. After doing that, we'll take that data and those images into Hammer missions in order to generate a 3D model.
Right, so that was some interesting flying, and now we're back in Hammer missions. And so what you see on the screen is the processed result of all that flying, which is essentially the roof that has been captured and 3D modeled in Hammer Hub. So basically, I've got a 3D model of the building that I've generated directly from the drone images, as opposed to images that are available through Google Earth. And if I had to sort of strike a contrast, so if you just look at the amount of quality you can get from drone data, so if you go to your imaging from Google Maps or Google Earth, and yes, you can get large areas, but you just generally can't get high quality when you zoom in. Things start sort of fading out, and also a lot of the times things are just not as updated as they would be with drone data, because after all, you've captured the data yourself at the time you wanted yourself, so you've got the exact conditions of the property as you would like, and you can basically use this to understand any part of the roof. What does that look like? You can zoom in, zoom out, pan around, play around, just like you would with a 3D model, and that gives you your first sort of insight as to how things are on the roof. Now, this particular project, we wanted to do two things. One is just look at the roof from a condition assessment point of view, and to be fair, the roof looks pretty okay from a condition assessment point of view. But some of the things that we did notice is that if you look at some of these gutters over here or places for drainage, you will sort of notice that actually some of these places might have accumulated water, or they might have leaves that sort of build up over time. And so you're able to pick up on those issues sooner than later, and you're able to actually do something about those issues once again sooner than later. You can not only look at the 3D model, but you can also look at the actual images. So for example, over here, I've got the actual images that I can zoom into, and let's say these leaves that I was talking about, if I find that to be a problem, I can just circle that as a potential issue, and I can tag that as a potential issue in the platform. So basically, all you have to do is go in and choose what kind of issue you might have. So over here, I've chosen leaves to be a potential issue forming. They might block the drainage, might cause other issues. And so you can essentially go in and tag all of these different issues. Now, this doesn't have to be just sort of property maintenance issues. These could actually be structural issues if you're looking at it from a engineering standpoint. You might have cracks on the roof, you might have missing shingles, you might have all sorts of issues that you want to report on, and that becomes really easy once you've got the drone imaging at your fingertips, so you can actually look at all of this data very, very easily. Right, so I'm going to delete that for the moment. And Right. Let's say the next thing we wanted to achieve in this project was we wanted to understand, well, how many skylights does this roof actually have? And we wanted to do a quick sort of inventory of how many skylights have been installed. And we wanted to just sort of output that into a report so that we've got that on hand in case we want to sort of provide that to a property maintenance technician. Now, one way of doing that is to manually count how many skylights you have on the roof, but we live in the times of AI, so why not let AI do some of the heavy lifting whilst we go and make ourselves a cup of coffee? So, in this project, what we did is we sort of highlighted a few example images of skylights. So, basically, allowing for some prompt into the AI. So, if you look at, let's say, this particular image of the project, we will actually find that there are some sort of examples that were annotated or tagged by a user as roof skylights. And using that, we were able to create an AI model for roof skylights and basically give it a name. And we have a roof skylight model that we can actually use to inspect or to map out how many roof skylights do we actually have on this particular project. So once that was done, AI was then used on the project, and the results is essentially we now have a majority of these images that have been tagged with roof skylights. So if we go in and look at any one of these images, we will see that the images don't only have annotations by the user, but they also have AI that has gone in and marked up all of these different roof skylights. And you can sort of see that they've been tagged by AI because it's got an AI in the tag, and it also gives you a little bit of a confidence score in terms of what the AI has been able to detect in this project. Now that's really interesting and really cool by itself that you go to an image, you've got all these different AI annotations. But the key question is, what do you do with all that information? Because it's all cool to detect all these different skylights, even the skylights that maybe were harder for you to detect. You can kind of find that AI will find them. For example, if you go to some of these skylights on the left-hand side over here, you might find that actually counting them by hand can be quite challenging. So, well, you can also use AI to actually quantify everything. So over here, you just use AI quantification, and it tells us there's about 80 skylights on this roof. 14 of them were found by a user, and 66 were found by AI. It also gives you the total square meter or square footage, depending on which side of the pond you're watching this from. It gives you total square meter or total square footage of the different skylights that have been found in the projects. And you can basically then also see tags that have been added by AI to all the different skylights that you will see in the projects. And that's as simple as clicking on the option to see where all the different skylights are, and it's been giving them its own unique ID for every single skylight. That's how it all works. And so you can see that very quickly we've gone from capturing drone data to processing it into a 3D model to finding all types of interesting defects or finding inventory of different equipment and giving them tags. And then finally, what we want to do to close off this project is to export everything into a report. So if I wanted, I could just export all of this data into a PDF report so that it can make its way onto different people's desks, people who need to make decisions off of it, because ultimately all data is useful data or becomes insight when you actually act on that drone data or any kind of data for that matter. So being able to get actions from your data is really important. And so what I can do here is I can add a summary paragraph. I can sort of say in this project, a roof was captured using a drone, 3D modeled, and inspected for condition. And finally, all skylights on the roof were counted as part of an equipment survey. So it's just really an example, but gives you a sense of what's possible. You can add your logo and branding to the report as well if you wish. You can add a summary paragraph, and we let it fire away. So we're going to give this a couple of minutes to generate. It's an automatic process, but we'll come back and see what the results look like. All right, so we've got our report generated. Let's have a look. So download the report and see how that looks like. And we go into viewing that report. And what we'll find is basically a description of the building, an introduction that we've added, a summary of the different issues, quantification, and then a table showing us all the different defects or issues that have been tagged. And then basically, if you click on any one of these, it takes you to the image and shows you where those particular inventory items are, and then also gives them its own specific annotation ID. And sometimes you'd find all of the different objects that have been mapped and essentially put into a PDF report. And that's basically it. You get a way to be able to quickly get to all the different inventory items that you might want to do, or you might want to actually detect defects. You know, you might have cracks and all kinds of issues forming on this particular roof, and you can actually get to them very quickly as well. So that's just a very quick sort of demonstration of how you can use drone data to capture, model, inspect, and analyze any roof and solve the difficult access problem the 21st century way. So, thanks so much for listening. If you have any questions, feel free to leave them in the comments box below. We've done tons of other videos on all sorts of different structures that have been mapped using drones and analyzed using AI. So, if you're curious, feel free to give them a watch. We'll see you in the next video for Hammer missions.